drum beat. Hello, Internet. Good evening, Twitch. It's me, it's your boy, it's Joey. And welcome to Everyone Loves Math Live, Monday through Thursday, 9 o'clock, until whenever. I'm here. I'm ready to do math problems. Let's see, we'll talk about this little program in a second, but we got a question from the chat, and I love myself some questions from the chat, and we're going to hit those up right away. How about that? Because it's Thursday, man. We got no time to waste. That's what I say. T Stove asked a question in the chat, and how about that? Look at that. It's right there. Boom. So the question from the chat is for us to solve this quadratic equation in the complex number system. So let's see. Those last three words scare me a little bit because it's like complex number system. That gives me a hint. So that gives me a hint that maybe the answer is going to be like disgusting. It might have some like imaginary number in it or something. Maybe it works out nice. I don't know. So let's work on solving it. So here's my thing. In this problem, they didn't tell us how they want us to solve it. So I'm going to go with a hunch. I'm going to go with the hunch that this whole complex number thing, I just have a feeling it's going to be ugly. I got a feeling. So let's see. If I have a feeling it's going to be ugly, then maybe I just do the quadratic formula and just start there. And then quadratic formula can handle ugly, right? So let's do that. Let's see. If I'm going to do the quadratic formula, this function's already set up for it because it's already equals 0. So what can we do? Well, if we're going to use the quadratic formula, A is 1, B is negative 16, and C is 128. So those are kind of ugly numbers. Numbers are kind of big, but it's all right. We can handle it. Let's do a little quadratic formula. All right, got to stretch. Ugh. Ugh. All right, so first thing to do is to remember what the heck the quadratic formula is. I know it's a big old fraction. How about x equals, say it with me now, baby, opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so we are going to put, let's see, 1 in for a, negative 16 in for b, 128 in for c, and take care of business. That's what we're going to do. So let's see here. Equal sign. Ooh, that's an equal sign. Big old fraction. Boop. All right. And let's see. Let's put some numbers in. So we have to start with the opposite of b. Well, b is negative 16. So the opposite of that would be positive 16. So that's where we're starting. The opposite of b. All right. Plus or minus the square root of b squared. So that's going to be negative 16 squared. Okay. Minus 4 times 1 times 128. Right? That's 4ac. And then all divided by 2a, which is 2 times 1. All right. So T-Stove, this is your problem. If you have questions, I can see the Twitch chat right there. So you can put that question right underneath your thing, and I'll see it. All right, let's simplify this thing. So we know the 16 is going to be there, the 2 is going to be there. We're going to have a plus or minus square root. I just did the easy part because I'm kind of avoiding the part that's a pain in the butt, which is the, what do we call that? Discriminant, right? Discriminant, the thing underneath the square root. So let's pop that thing out to simplify it. All right, so negative 16 squared. I know that's going to be positive because it's negative times negative. With a calculator, that's 256. And then we have minus 4 times 1 times 128. So we know that's going to be subtract. And then on my calculator, I'm going to do 4 times 128, which I think I know what that is. But after 9 o'clock, my ability to do mental math is diminished. That's 512. Okay. So let's see, 256 take away 512 is negative 256. And so that is the thing under the square root. All right. So let's check back in. So what we just did was we were asked to find, I'm going to go back up here, to solve this thing in the complex number system. And so to me, that said the answer's probably going to be ugly. An ugly answer means I might as well just quadratic formula that bad boy. So we did the quadratic formula. There it is. And now we have to interpret our answer. So interpreting this answer kind of depends on what math class you're in. So if you're in like Algebra 1, the answer is like almost literally the answer to an Algebra 1 student would just be a frowny face. Why would it be a frowny face? Because an Algebra 1 student knows that if you have a negative under the square root, there would be no real solutions. So the more professional answer in Algebra 1 would be no real solutions. But I happen to know that this question is from pre-calculus, and in pre-calculus, they don't accept no for an answer. We can still do some work. And so what we need to do is we need to clean up the square root of 256. So here's what we'll say about the square root of 256. And oh boy, I thought I was using this button. So I'm going to go over here and clean up this square root of 256 again. Or I'm sorry, square root of negative 256. So we have the square root of negative 256. And I'm just popping this off to the side because I want to organize my thinking. Even though this might look disorganized, I don't want to have to be like copying the whole problem over and over and over again for just one part. All right, so how do we simplify a square root when there's a negative inside? Well, we split up the square root, and in this particular case, we can split it up kind of, not too bad. I'm going to write negative 256 as 256 times negative 1. All right, why am I going to do that? Because the square root of 256 is 16. So 256 is a perfect square. The square root of 256 is 16. And the square root of negative 1, once you're in pre-calculus, is the imaginary number I. So in this particular problem, the square root of negative 256 needs to simplify to the to 16i. So we're going to put that in and get closer to our answer here. So going back here, we would write this problem as 16 plus or minus 16i divided by 2. And we could leave our answer like this. However, this simplifies because you notice that the numerator has the 16 and 16. We could divide that by 2. So let's simplify this. I'm going to factor a 2 out of the numerator so that I can cancel it with that 2 in the denominator. So if I factor a 2 out of the numerator, let's see, 16, factor out a 2, I'd be left with 8 plus or minus 8i. Where'd that 8i come from? Because if I have 16i and I factor out that 2, then I have 8i. Alternately, we could say 8i times 2 gives us that 16i. All right, well, all of that having been said, the 2's now simplify to make 1, and we are now left with the answer to this problem. So the answer to this problem, let me get my pretty color. Gotta have pretty color, gotta have blue. The answer to this problem is 8 plus or minus 8i. Of course, if we wanted to list out those answers would be 8 plus 8i and 8 minus 8i. All right, and those would be the answers to this problem. Now, what I'm going to do before we're done with this problem is let's go back and graph this thing in Desmos so that we can see, because this is just a quadratic, we should be able to see what this quadratic looks like in Desmos. All right, so I'm going to go to Desmos. There we are. Ooh, I still have an old problem on here. Let's get rid of that. And now I'm going to graph this quadratic. So I'm going to put in x squared minus 16x and then plus 128. All right, so I put in that quadratic and I can't see anything. So let me zoom out and see what's up. Something must be happening. Oh my goodness. Look at that. There's that quadratic. What do we notice about this quadratic? It is it's way up there. So think about this. Let's see, where's my little pointer? Right about here. So this is right here where the zeros would be, right? The x-intercepts are zeros. This quadratic that's way up there, that's never, oh, let me see. You can't see what I'm pointing at. How about this? So the zeros would be down here. This is where the y equals 0. But the quadratic that we're looking at is way up here. So you can tell by this graph, and of course we can zoom out some more if we want to be absolutely sure. But if we look at this graph, this function never touches the x-axis. So this function has no real zeros. That's why its only zeros are complex. They don't show up on the graph. All right, T-Stove, keep feeding me problems, and we'll keep doing them. And let me see, before I move on, any questions about that, T-Stove? What is the conjugate? Ooh, they're feeding you stuff. Ooh, conjugate. Let's talk. All right. So we're going to talk about conjugate. All right, cool. So the conjugate of -7 minus 3i. Okay, so here's what I'm going to do. T-Stove, I'm going to give you the answer, and then we're going to go back and figure out why that's the answer. So first of all, let me give you the good news. If because all of this is in, I will tell y'all, T-Stove is a pre-calculus student. So we're looking at some pre-calc, and we're doing some, what do we call these? The polynomial functions. So the conjugate, here's the good news. And again, I told you I would start with the answer. The good news is that this is a problem we can do in our head in less than 5 seconds. How great is that? So here's the answer. The conjugate of -7 minus 3i is -7 plus 3i. Done. That's the answer. Of course, if I stop there, this does no good in having you get other problems right. So now that we know the answer, let's back up and talk about the conjugate. So when we talk about conjugates, it's almost always we're talking about either stuff with imaginary numbers in them, like this, like complex numbers, or we're talking about some stuff that has square roots in them. Those are the two times where we're asked about conjugates. So here's what we need to know for the future. What do we know about conjugates? So conjugates, like this concept of conjugates, is based on, and here's something really random, the difference of two squares pattern. I felt like writing this. I don't know why. So conjugates is based on the difference of two squares pattern from Algebra 1. That's what it's based on. All right, so again, we're going to take a little bit of a walk, but we're going to get there. So let's talk about the difference of two squares pattern. So where do we have that difference of two squares pattern? If you remember, the difference of two squares formula says a squared minus b squared. Remember, that's a difference, right? Minus of two squares equals a plus b times a minus b. So this is this is a property that we learned in Algebra 1. We can prove this property, and we use this all the time in Algebra 2 and pre-calc. This shows up all the time because this is actually an easy pattern. So whenever we see this, we celebrate. Look what happens if we multiply out, and I'm going to use the area model to multiply it out. Look what happens if we multiply out a plus b and a minus b. All right, so we're going to take this thing and multiply it out just to show that it really does equal a squared minus b squared. So let's see. We've all done this before. So in this first box, we're going to do a times a. That would be where that first box goes, a times a, and that's a squared. For as we continue to multiply, we have a times, for this box, the opposite of b. So that's going to be the opposite of ab. Bottom left corner, we have positive b or plus b times a. That's going to be plus ab. And then for our very last box, that's where we multiply positive b plus b and minus b, and that turns into minus b squared. Okay, so have we proved the difference of two squares pattern? Well, pretty much. If we look at this thing, look at this middle diagonal here, negative AB and positive AB, those are opposites, so those cancel out. So what we're remaining in this problem is a squared minus b squared, which is exactly what we have right there. So that's just a quick review of the difference of two squares pattern. Okay, so now we gotta go back, and what the heck does difference of two squares have to do with conjugates? Well, you might already see the connection. Remember how difference of two squares was a plus b and then a minus b? Let's see what happens when you multiply two conjugates. Okay, so we're going to use difference of two squares, except instead of a and a plus b and a minus b, I'm going to use these. And I'm going to show you what happens when we multiply two conjugates. So here we go. We're going to multiply negative 7 minus 3i and negative 7 plus 3i. Again, I'm here to annoy you. We got this answer already. We got it already. And I showed you, when it's a conjugate problem like this, you can spit out the answer in less than 5 seconds real quick. But now we're going back so that you see why it actually works, so that you don't have to remember this in the future. So I've already declared that these two things are conjugates. Now 7 minus 3i and negative 7 plus 3i, those are complex numbers. They're disgusting, right? Those are disgusting complex numbers. But look what happens when we multiply two complex conjugates. Something really nice actually happens. And that's why this whole thing exists. So again, I'm going to use the area model to multiply these. Negative 7 minus 3i. We're going to multiply by negative 7 plus 3i. All right, so let's see what happens when we multiply these out. So, first box right here comes from multiplying negative 7 and negative 7. Negative times negative is positive. This would be positive 49. All right, how about upper right? Well, this box would come from multiplying negative 7 and positive 3i. So that's going to be negative 21i. Okay, following our nose. Bottom left box. So that's going to be negative 3i times negative 7 to go to that bottom box. Negative times negative is positive, so this would be positive 21i. Look at that negative 21i and positive 21i. Oh boy. All right, last box. Down here, we multiply negative 3i and positive 3i, and that's going to make minus 9i squared. All right. So I told you something nice was going to happen. And you're probably saying, what nice is going to happen? This still looks disgusting. And I would say, hang on just a second. Because here it comes. This is the big payoff. Hold your applause. So now let's pop this stuff out of the box and see what we got. This thing is 49 minus 21i. Oops. Plus 21i. Minus 9i squared. Okay. So trust me when I tell you, this is about to get kind of pretty. How is this going to get pretty? Well, negative 20... Ooh, I should use a different color. Yellow is kind of hard to see, is it? Negative 21i and positive 21i, those cancel out. Something else nice happens. So I'm going to leave this 49 here. I squared is negative 1. because the I squared is defined to be -1. That's how imaginary numbers work. So, again, following our nose, this is 49 plus 9, which comes out to 58. And so, remember, I promised you something cool was going to happen. Something cool just happened. That was it. That was it. That was the cool thing that happened. Oh my goodness. My definition of cool just does not work, man. Okay, so let's go back and talk about what cool thing just happened. The cool thing that just happened in this particular page was that we started with two complex numbers. These are both complex numbers with imaginary parts. Ugh. And because they were conjugates, because these two complex numbers, -7 minus 3i and -7 plus 3i, are conjugates, then when we multiply conjugates together, look at what the answer is. It's not a very special number. It's the number 58. But notice, 58 is pretty. That's a whole number. So here's the idea with conjugates. Conjugates follow the difference of two squares pattern, so that if you multiply two complex conjugates, you end up with a pretty number, either an integer or a fraction. No square root, no imaginary number, none of that. So that having been said, T-Stove, let me show you another problem, because I can almost guess what the next problem is going to be. We could ask something like this. We could say, what's the conjugate of, and remember, I could give you a number with an I in it or a number with a square root in it. So let's do another one with an I in it. I could say something like 7 plus 2i. Okay, so what you have to tell yourself is that's an ugly number. Conjugates follow the difference of two squares pattern. So if you remember what I just said, the difference of two squares pattern is that a plus b, a minus b. So the conjugate of 7 plus 2i is 7 minus 2i. Again, if you understand conjugate, this is a 5-second problem. If you want to prove that these two are conjugates, multiply them out, and I bet they come out to a whole number with no i's in them. All right, I'm going to give you one more, because they could ask this one other way. They could say, what's the conjugate? And give you something like this. Let's do 5. So this is another disgusting number. 3 plus the square root of 5. You put that in your calculator, it's disgusting. Goes on forever. It's all gross. Bad things happen. Disgusting. But if you remember in your head what we just went over, that conjugates, whenever you hear the word conjugate, think about the difference of two squares pattern, then again, you can get this problem right in 5 seconds. The conjugate of 3 plus the square root of 5 is 3 minus the square root of 5. All right, so that's that conjugate problem. The conjugate pattern. It always follows difference of two squares. All right. So that was great that we had a question to start things off. I'm going to go back and say, hey, what's up, everybody? Happy Thursday. Once again, I'm Joey. I run this website called Everyone Loves Math. And for this website, hey, look, it's, it's, and we go here, beep, beep, and I push this button, boop, boop. Look, there's my website. How about that? everyonelovesmath.com. So if you go to this website, you'll see a link to this live show that you're watching right now. So this show is Monday through Thursday, starting at 9 and going until question mark. It depends how many questions I get. The front page of my website has a link to the show you're watching right now. We do it live at 9 on Twitch, and then the next day the archives are up on YouTube. There is a link for tutoring, so let me just show you that. If you click the link for tutoring, this will open my calendar, and I have all my availability up for the next 60 days. You can book a session. Boom, it'll work. All right, boom. The other thing on everyonelovesmath.com is my message boards. And right now, there's not a whole lot going on my message boards. I'm going to be honest with you. I'm still building this up. But this is a place where between shows, if you would like to go onto the message boards, you can ask a question. And then that night or the next show, I will do it to lead off the show. How about that? There are two levels of membership. There's a free level and a $5 a month level. Right now, the $5 a month level gets you into the VIP Q&A message board, but honestly, it's just a way to support me. You become an ELM supporter, and Everyone Loves Math supporter, because the work that we're doing on this show is important, and you want to support it. You are not going to make me mad if you join the free part, and you can still ask questions, and they will still be prioritized on our show. So that's Everyone Loves Math. Again, this show that you're watching right now, Monday through Thursday, 9 o'clock live. If you give me a follow on Twitch, it's free, and that'd be awesome. Yeah, we'll just continue to do some math. So let's talk about how this show goes, because for each night, it's always somebody's first night watching the show. So here's what I do. First of all, my name's Joey. I've been a math teacher forever. I've also been an assistant principal, and I've trained teachers. I've trained math teachers. I've trained Spanish teachers. I love math. I do. And I love working with math students. And so this is a way that we get to work together for free on Twitch. That's cool, man. I love doing it. So what do I do? Well, I would love to just build this show with math questions from y'all. So keep them coming in the chat, and we'll keep doing them. Ain't no problem with that. And then when there aren't questions in the chat, what I do is I go on to Reddit, and I just pull questions from there. And so I've got questions every night. I always have like a backlog of questions loaded up from Reddit. But if there are math questions that you want to drop in the chat, you can drop it during the show. If you put it in Twitch chat, I'm going to see it right away. Okay? The other place where you can send questions, and it's showing up right now down here, is the Everyone Loves Math hotline. So that is the Everyone Loves Math hotline, is also known as my Google Voice phone number. And you can text me, send a photo of like some work you're doing. You can even record a video and explain where you're stuck. And if you send a question to the Everyone Loves Math hotline, that's another way to get it on the show. Really, I want to do questions that help you out. So if there's another question you need, T-Stove, put it right in the chat and we'll do it. Not a problem at all. Okay? So when there aren't additional questions, like I said, I just go from Reddit, and so we can do Reddit questions. So let's see. Ooh, T-Stove is on fire. T-Stove asking all kinds of questions. All right. So this is a great follow-up. So if y'all see T-Stove's question in the chat, it says this: 7 plus 5i is a zero of a polynomial. I don't even care that it has degree 5. So here's the funny thing, right? Polynomials, let's talk about them, right? So anyway, this problem says it's a zero is a zero of a polynomial of degree 5, and then it says with real coefficients, okay? So real coefficients mean that they're either like, fractions or square roots. There's no imaginary stuff, right? Real coefficients. So let me just like invent a fifth degree polynomial, okay? So I'm going to say something like this. It could look something like this. Don't write this down. This is just a fifth degree polynomial. Maybe 8x to the 5 minus 2x to the 4 plus x to the 3 minus 7x squared plus 5x plus 12, right? So maybe that is the fifth degree. Maybe this is it, right? Maybe that's the fifth degree polynomial with real coefficients. So here's the funny thing, and you're about to get some good news. This problem is, oh, you can't see the whiteboard. Oh my goodness, how about that? Boom. All right, you got me too excited. All right, so let me start over then, okay? So it tells me that 7 plus 5i is a zero of a polynomial, some fifth degree polynomial. So here's what I did. I came up with some fifth degree polynomial. Look at it. There it is. Blah, 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 blah. It's all disgusting, okay? Except it's not as disgusting as it could be, because check this out. This polynomial, if this is true, has this ugly 0. It has this 0 that is 7 plus 5i. But wait a minute. I don't see any imaginary numbers. I don't see any i's in this polynomial. So here's what must have happened. By the way, what I'm explaining to you, like, always happens. Okay, so if 7 plus 5i is a 0, then there must be another 0 for this polynomial, where if you multiply those zeros together, everything got pretty. There must be some way to hide that ugly, right? 7 plus 5i is an ugly 0. And so how do we hide an ugly 0? You're never going to believe it, T-Stove. You hide an ugly 0 by saying that its conjugate must also be a 0. 7 minus 5i must also be a 0. All right, so the answer to this problem would be 7 minus 5i. So here's what's cool about that. What pattern is that? What's the word for that? Ooh, type it in the chat. Type it in the chat. What's the word for this? 7 plus 5i and 7 minus 5i. Give me that word. Give me that word. Put it in the chat. Put it in the chat. Put it in the chat. What's that vocabulary word? Ooh, somebody type it. Somebody type it. Come on, chat. You get bonus points if you type it. What relationship do those two have? 7 plus 5i and 7 minus 5i. Yeah, that's right. Those are conjugates. So the reason why we're talking about conjugates for the last 3 problems, and the reason why I broke this down a little bit, is that this is the power of conjugates. So here's what you need to know. If you have some ugly 0 in a polynomial, then its conjugate must also be a 0. Because when you multiply conjugates, you end up with something pretty. Conjugates is a way to hide the ugly. So there might be something called like the conjugate theorem or something. Like probably there's a way to make that official. But who cares? It's not even named after a person, right? It's not even that big of a deal. So what we want to say is that whenever an ugly 0, like with an I or a square root, is a 0, then its conjugate must also be a 0. All right, very nice, T-Stove. Man, you're on fire. You got another one for me? We can do another one. I can do T-Stove problems all night. I don't care. I'm having a great time. I love polynomials. All right. Yes, yes. All right. Give me a thumbs up in the chat if you love a polynomial. While T-Stove types her next one. All right. T-Stove is typing her next question. His or her next question. You don't know. I'm just dancing. I'm dancing today. I don't know. I've had this energy. What's up, y'all? Hello, Internet. Just to catch everybody up, T-Stove is typing in I think, a polynomial math problem. We're doing math right now. If you have math questions, type them in the chat. We got you. If I run out of questions, I go to Reddit. So I'd rather answer your questions. Doodly doo ba doo 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 doodly doo. All right. All right. Oh God. T-Stove's been typing for a while. That might mean this next question's going to be a beast. Maybe we get a little drum beat in there. Okay, there we go. All right. So, find the remaining zeros of f. Okay. So let's see. We have f of x. So I'm going to paraphrase what you wrote, Stove. So we have f of x whose coefficients are real numbers. So that means it's a pretty polynomial. That's like all polynomials, man. You're not going to see polynomials that have i's as coefficients. And then it says find the remaining zeros. So let's see. Of f. The zeros are 1. Let's see here. Stove, did you type in the function? So the zeros are 1 negative. Let's see. I think you typed it in wrong. Because if the zeros are 1, -1, and negative I, then it can't be a degree 3. So there's something funky about this problem. Just snap a picture and send it to the hotline. I won't put your picture up. I'll just use it to see it. Let's see. 727-371-6464. That is the Everyone Loves Math hotline. You love it. All right, y'all. While I'm waiting for this picture, if you haven't followed, give me a little follow. I'm trying to get myself up to 50 followers. Spread the love of the math. Doodly doo. Do doodly doo. Let's see. All right. Let's do a little drum beat while we're waiting. That's a little drum beat. Cool story. I'm not wearing my headphones, so I can't hear the drum beat. So I'm not dancing in time, which is very on brand. All right. Ooh, sent. Boom. There it is. Okay, I got it. Let's see here. Boo, boo, boo. Doodly doo doo. Doodly doo. All right. So it's whose coefficients are real numbers. Find the remaining zeros of f. So oh, now I see what it is. Now I see T Stove. So it says it has zeros. 1 and then -1 minus I is a 0 and is degree 3. Okay. Man, sorry, I should have known what you were saying. I think you might have put a comma in there, or it's my bad. Either way, we're good now. Ooh, I need to turn down my drum beat. All right, sorry, that was our waiting for questions. Okay, so here's the thing. It's a third degree. It's a degree 3. So that means it has 3 zeros. So let's look at this. Third degrees. Oh, you did put an extra comma. Don't do it again. Okay, so this thing is a third degree, so it should have 3 zeros. Well, here's 1, and here's 2. So what we know is that this thing must have a third 0. Well, are you ready for this, Stove? One of the zeros that it gave us, remember, it gave us 2 zeros, right? This one and this one. Isn't this one ugly? There's an ugly 0. -1 minus I. Oh, ugly. You're ugly. So we said there's a third 0. That third 0 must be the conjugate for Mr. Ugly. So the third 0 must be -1 plus I. That's it. So this conjugate thing, we're getting some mileage out of it. It's almost like I knew this was coming. So here's what we got to know. This is like the big moral of the story. Okay? Ugly zeros. And Stove, if you got another question you want to put while I'm writing this, go for it. So ugly zeros, and by ugly zeros we mean either stuff with I that's complex, right? or stuff with square roots, which is irrational, right? So when we're talking about ugly zeros, that's the kind of stuff we're talking about. Ugly zeros appear in conjugate pairs. So in this problem, even though it was written different, they gave us an ugly zero. And at this point, from here on out, you got to be Terminator about it. You got to be like, "Oh, they gave us an ugly zero, but it works out nice. Oh, that means the conjugate of the ugly zero must be in the house." So the conjugate of -1 minus I is -1 plus I. All right. There we go. See all this mileage we're getting out of conjugates? We're getting so much mileage. All right, same type of question. So now we have a degree is 5. Okay, so let me write this in here. So we got a function, f of x. All right, so it has degree 5. So that means there could be, degree 5 means there's 5 zeros. Some of them might be imaginary or complex, but there'll be 5 of them. And it says the zeros are, all right, let's see, -5 is a 0. Okay, all right, -5 is a 0, that's fine. I is a 0, uh-oh, that's ugly, you ugly. And -7I is a 0. You ugly, ugly. So, yeah, let's do it. Let's do it. I'm gonna point at these things and call them ugly. Okay, point at them, call them ugly. There we go. It's our turn. It's our turn to take revenge. Look at you now. Who's ugly? You imaginary number. Okay, so we have 2 ugly zeros, but what did we just say? Ugly zeros always show up in conjugate pairs. The problem is that these don't look like the other conjugate problems we did. So here's how we got to write it, right? So what do we got? We got I. So I is a 0. But if I want to find the conjugate of I, then I need to make I look like the difference of 2 squares pattern. So I'm going to call it 0 plus I, right? I is the same as 0 plus I. And so the conjugate of that would be 0 minus I. So, and another way to say 0 minus I is negative I, or minus I, okay? So here's what we can say. If ugly little I is a 0, then its conjugate, negative I, must also be a 0. Ugly comes in conjugates. So 0 plus I must have its conjugate pair, or its conjugate partner, 0 minus I. All right. -7I. So if -7I is a 0, well, that's ugly. You're ugly, -7I. Face the facts, man. So, but what that must mean is the conjugate of -7I must also be a 0, because somehow this all works out pretty. So how do we find the conjugate of -7I? Well, we make it look like the difference of 2 squares pattern, 0 minus 7I. And so its conjugate must be 0 plus 7I. Remember that difference of 2 squares pattern. Well, no one would ever say 0 plus 7I. We would just call that 7I. So here's the story, Stove. Let me try to fit all this on here, okay? If -5 is a 0, so be it, all right? -5, that sounds like a good 0, right? I can imagine that. Fine, whatever, throw that away. If I is a 0, ooh, I, you ugly, you're ugly. Your conjugate must also be a 0. -7I is a 0. Ooh, you're ugly. Your conjugate must also be a 0. So the way we look at this is anytime, if they give us a pretty 0, good, you're on the list. Cool, come on in. Any ugly 0, its conjugate must also be on the list. Okay? And now, by the way, just because I'm a math teacher and I have to do this, how many total zeros did we just find? Remember, we said this was a 5th degree. There's 1 0, 2, 3, 4, 5. So sure enough, there are 5 zeros. It just so happens that only one of them is pretty. The other 4 are ugly zeros in their conjugate pairs. All right. Let's see. Stove, was that cool? This is just more conjugate use. I guess I moved past that. So I knew they were going to ask that. So when there's just an I, we have to make it look like the difference of two squares pattern, and that'll help us find the conjugate. All right. Well, this has been fun. This is fun. Oh my gosh, it's already 9:46. We do a couple more problems. Oof. Oof. All right, Stove, you got another one? I'll do another one. T-Stove 1 and T-Stove 1 gonna ask some questions for me. All right, it's not liking that answer. Okay, did you type in the negative I? So if you're typing in your answer, Stove, the answers you should be typing in are negative I and 7I. Those would be the two other zeros. You don't type in all 5 answers because it already gave us those 3 up there. So you type in negative I and positive 7I and it doesn't like that? Oh, all right. There you go. Bet you forgot a minus sign. Everybody forgets the minus sign. All right. All right, Stove, we still going? You got another one for me? Or anybody else, man. Anybody else besides Stove. If you got a question, put it in the chat. Math questions. I got you. Yes, sent it to the text. Ooh, the text. Also known as the Everyone Loves Math hotline. I have to make it sound official, you know. Okay, here we go. Another one in the boop boop. Okay. Oh, they keep messing with you. Oh, I love this. They keep messing with you. They're so mean. I love it when people are mean. Okay, so this next question. We're just making it a polynomial night up in here. So what is f of x? F of x is degree 4. So that means it's going to have 4 zeros, right? Who knows how many it'll be disgusting, but it has a total of 4 zeros, and it gives us some of them. All right, so what are the zeros? The zeros are negative 4 minus 5i. That's a 0. And then it says 1 multiplicity 2. Okay. So here's what we're going to do, Stove. I'm going to help you with the new piece, and you're going to help me with the old piece. Okay? So we haven't talked about multiplicity. This is the first time that showed up. What I always think about is it's a really nerdy way to say something, this multiplicity thing. So I'm going to erase it and put what it means. All right, and then you'll see. I always like this because I just imagine a nerd saying this. What this really means is that these are the zeros. Negative 4 minus 5i, and then it said 1 is a 0 of multiplicity 2. All that means is that 1 shows up twice as a 0. That's like the nerdiest thing ever, right? We could just say 1 and 1, but I just like, it's a multiplicity 2. Like, you know, my eyeballs are of multiplicity 2 because I have 2 eyeballs. My fingers are multiplicity 10. Yeah, that's just a nerdy way to say I have 10 fingers. Okay? So, I took care of that part. Now, T-Stove. 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 Look at that 0. Look at that 0, T-Stove. Say it with me now. Negative 4 minus 5i. You ugly. You are ugly. Not you. I shouldn't point. I'm pointing at negative 4 minus 5i. I'm sure you are wonderful, but negative 4 minus 5i is ugly. So what does that tell us? What also must be a 0? How do you hide ugly? Type it in the chat. Type it in the chat. If you take a guess, it'll probably be right. Type it in the chat. Mm-hmm. Dude, check that out. The only way to hide ugly is with its conjugate. Negative 4 plus 5i must also be a 0. So stove, that's your answer. Okay, and by the way, remember when we said this was 4th degree? Right? This was a degree 4? Well, let's go back and... Ooh, let me move this so we can see it. So let's go back and look at it. Does this have 4 zeros? You better believe it has 4 zeros. Those 4 zeros are negative 4 minus 5i, negative 4 plus 5i, 1, and 1. Those are the 4 zeros. The only difference is instead of saying, 1 is a 0 twice, it says 1 is a 0 of multiplicity 2. It has multiplicity 2. Please do not stuff me in a garbage can. But it is a 0 of multiplicity 2. Yeah, man. Yeah, man. Do-do-doodly-doo. All right, I got a feeling I might be getting another problem in the old Everyone Loves Math hotline. Drop it in the chat, or send it to the hotline. All right. Yeah, stove. I think I might have time for like maybe 2 more, maybe 3 more. We'll see. I'll do 3 if you want to do 3. Oh, another one just came in off the hotline. Oh, don't be talking to me like this. Negative 4 minus 5i. Well, you didn't show me what you typed in. What'd you type in? Let me see here. Let's see here. Guess what? We answered the wrong question. Okay. F of x equal, let a equal, using x as the variable, use integers or fractions. Oh, okay. Interesting. So what they want us to do is they want us, stove, that's why the instructions changed and I didn't read the instructions carefully. What they want us to do is they want us to write out, oops, I hate that color. They want us to write out f of x. So instead of saying the zeros, they want us to write it as factored, in factored form. So what they said is there could be a constant out front and then a parentheses. All right, so type an expression using x as the variable. Okay, so let's give this a shot, okay? So stove, now we're going to use that opposite relationship between zeros and factors. All right, so we're going to see, because depending on the program, they could accept a couple of different things as answers, okay? So if you remember, zeros and factors have that opposite relationship. So for example, I'm going to do the easy one first. Remember that 1 is a 0 of this polynomial? So x minus 1 must be a factor. Remember that opposite relationship. So this time, instead of asking us for the zeros, they're asking us for the factors. Okay. But remember, 1 shows up twice. So we're going to put another copy of x minus 1 in there. Right? This is a 4th degree polynomial, so we need 4 factors. Okay. Things are going to get a little ugly again, but that's okay. Remember, zeros and factors have that opposite relationship. So if negative 4 minus 5i is a 0, then x minus that, negative 4 minus 5i, is a factor. Even though that looks ugly, we technically have to write it if we're going to be mathematically stubborn. And then, ooh, I need some more space. So let me move. Man, I wish I could do that with normal paper. And then the conjugate must also be in here. So x minus negative 4 plus 5i. So Stove, you're comfortable writing out the zeros. And I know, because we've done this before, that you know the opposite relationship between zeros and factors. It's just that opposite relationship also proves true when the zeros are ugly. All right, so we did need those conjugates. And we could type this in as our answer, but I'm going to clean this up one more step, okay? So there's a constant potentially on the outside, and then the x minus 1 and the x minus 1. Now I could write this as x minus 1 squared, right? I could write that instead. All right, next up, what I'm going to do is I am going to distribute this minus sign. All right, at this stage of the game, we're just cleaning this up a little bit, like the bare minimum cleaning up. So we're going to distribute this minus sign. This is going to make it x plus 4 plus 5i. Right, if we hit negative 4 with that minus sign, that's going to go positive. If we hit negative 5i with that minus sign from there, it's going to go positive. And then our last factor is going to be x, and then we got to do our little rainbows again. Boy, take that negative sign and distribute it. So we're going to get plus 4, right, minus negative 4, and then minus 5i. All right, so instead of listing the zeros, now we have rewritten f of x using its factors. It's the same idea. We just had to read the problem a little more carefully. And by we, I mean me. I had to read the problem more carefully. And this is what we're gonna put in. Stove, keep in mind that when you go to type this answer in, the A is already in the answer. So you actually don't have to type the A in. You just do the rest. Okay? All right. Sorry, Stove. We got you now, though. All right. So, Stove, are you cool, or you got one more for me? You sending one more down? Do one more, and then I might call it a night for tonight. Just for tonight. Be back on Monday. Okay, here we go. Ladies and gentlemen, our last polynomial question of the night. It's coming into the ELM hotline. Here we go. Boop, boop, boop. Oh, okay. So, that's insane, Stove. So I will tell you this. They did not. So here's the story for everybody watching. So we did this problem, right? And Stove, I know, is working on a little review. Stove typed this in, and it came out incorrect. And what they didn't say, that they want us to take this thing, and they wanted us to multiply it out. That's what they wanted. They wanted us to multiply this thing out. That's disgusting. I cannot believe they would want us to multiply that out. That's really gross. That's like really gross. I will multiply it out with you. I'm going to multiply it out with you. But gosh darn it. That's all I got to say, okay? All right. So, oh my gosh, how do we multiply this out? It's going to make me do another. Okay. All right. So maybe we'll do one new one, and then we'll so that I don't have to multiply both of these out. So, yeah, that's really mean. And at the very least they could have done is tell you, hey, please multiply it out, because what we typed in as the answer, based on what they asked, was correct. So I got beef with them. but that's okay. We'll do one more fresh. They did us dirty. Did us dirty. The dirtiest. Did us the dirtiest. Real dirty. You know it. Haters. That's what it is. Haters. Okay. All right. We're going to do another one just like it. It's a real power move to be that dirty and then give us another one. All right. F of x has degree 4. All right. So that means there's going to be four zeros. There's going to be 4 factors because factors and zeros related. All right. So then it gives us a list of the zeros. So the zeros that we for sure know about are 3 minus 2i. And then, oh, look, 1 of multiplicity 2. So that means 1 and 1. 1 of multiplicity 2. All right. So Stove, type me in the chat. What's that missing zero? What missing zero do we need to add to this list? And if somebody wants to beat Stove, beat Stove. What's the other zero? We've got 3 of them. You see them. 1, 2, 3. What's our 4th one? Yeah. Yeah. The conjugate. Man, did we spend the whole hour talking about the conjugate? I never thought I'd spend an entire hour talking about a conjugate. That's wild. All right, Stove. We're going to, so those are the 4 zeros. And by the way, check it out. 1, 2, 3, 4. We know all the zeros. And if we know all the zeros, then we know all the factors. And if we know all the factors, then we can rewrite f of x. And that's exactly what's going to happen right now. So what are we going to write? We're going to write f of x equals. Oops, I know you can't see that. So I'm going to move f of x equals. I mean, I can't move like my... You have to see the eye candy. You got to see the moneymaker here. There we go. All right, so what are we going to do? Well, there could be some constant out front. We don't know. But besides that constant, we're going to have 4 factors. So I'm going to put the pretty ones up front just because that's what I feel like doing. The order doesn't matter. But we know x minus 1 shows up twice as a factor because 1 showed up twice as a 0. Then we need to have x minus parentheses 3 minus 2i. And then x minus, in parentheses, 3 plus 2i. All right. Oh, man, you're going to put some money in the tip jar for this. I'm going to tell you. All right, so now we're going to still clean up those ugly parentheses inside of parentheses. We're still going to clean that up. So let's do it. There's going to be this constant out front. I'm going to leave the x minus 1s for now. Next, we're going to do our little distributive property rainbows with that minus sign. So we end up with x minus 3, because minus to the 3, and then the minus hits the negative 2i, so that'll be plus 2i. And then for our last factor, we have to also distribute out those that negative. So this will be x minus 3 minus 2i. All right. And now it is time, because the problem, even though it didn't tell us it thought we were psychic, it is time for us to multiply this thing out. OM goodness. Okay. So here's what we're going to do. And again, I'm having a great time. So here's what we're going to do. We're going to take, because there's 4 things to multiply out, right? There's 4 different factors. So I'm going to multiply out the x minus 1s first. Okay. And then I'm going to make a 3 by 3. Yes, a 3 by 3 to multiply out the other 2 factors. Why do I need a 3 by 3? Because I have to multiply x minus 3 plus 2i and x minus 3 minus 2i. Oh, I can watch the viewers drop now. Um, so here's what we got to do. We're going to multiply both of these out, clean them up, and then once we get answers to both of them, then we have to multiply those together. Uh-huh. Yeah. Yeah. Right? Because so far what we're doing, and I don't want you to lose track of what we're doing in this problem, we're multiplying these together, and we're multiplying these together. When we're done, we're going to get the answer from both and multiply those together. It's going to be wild, bro. Let's do it. I'm so excited. Let's go. All right, so I'm going to do this part quickly because I don't want to get bogged down in the algebra. If we multiply here, we get x squared minus 1x plus 1. Right, we multiplied, do the pimple popping to multiply that out, and we already did that a couple times during this hour, so I feel okay about that. Now we've got a 3 by 3 to multiply out. Okay, this still works. This box is going to be the x times x. So I always say you pop the pimple. So whatever box you go, you look at that row and that column and multiply. This is the way that we're going to organize our multiplication problem. So x times x is x squared. X times minus 3 is minus 3x. X times minus 2i is minus 2ix. Ugh, gross. Oh my goodness. Okay, next row. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. And negative 3 times negative 2i, negative times negative is 6. Oh, I'm sorry, negative times negative is positive, and that would be positive 6i. Woohoo! Get it. All right, last row. 2i times x is 2ix. It's plus 2ix. 2i times negative 3 is negative 6i. And 2i times negative 2i is negative 4i squared. Ha ha ha! Ha ha! Whoa! Multiply party, multiply party. Okay. So now we're gonna let's start to clean stuff up. Let's start to clean stuff up. Oh, stove. Look what you made me do, stove. Okay. So the first multiplication problem that we did, I'm gonna give us a little space here. I'm talking about this one right here. That first multiplication problem. This is x squared minus 2x, right? Those combine, the minus 1x and minus 1x. That makes minus 2x and then plus 1. So down here, give me some space here. I'm going to write x squared minus 2x plus 1. Okay. Now we need to put what the heck came out of this one. This disgusting one. Now here's the thing. Remember the negative 3 plus 2i and the negative 3 minus 2i? These were this one that we're about to do. This is where stuff got ugly. But not only did stuff get ugly, but we specifically picked the conjugate as a 0, right? Remember when we did that conjugate? We multiplied two factors that have conjugates. Well, look what happens. We're going to take any success, any victory where we can find it, and we actually do have victory here. You know why? Because look at this bad boy right there. See that? That's a 6i. I spy, with my mathematical eye, a negative 6i. Oh, look. Those make 0. That's the magic of conjugates. Wow. I'm sorry, that's as cool as I can make it, okay? Conjugates, remember, all the ugly stuff is going to cancel out. Speaking of ugly, 2ix and negative 2ix. Bye-bye. Those make 0. Those are opposites. Okay? There's only one more thing that has an I in it, and in fact, it has an I squared. So it's this thing, negative 4i squared. But here's the thing. I squared is negative 1. So this is really another way of saying negative 4 times negative 1. So that last box, even though it has an I in it, because it's an I squared, that just simplifies to positive 4. It's almost too easy. Yikes. Okay, so now that we've done all this math, believe it or not, we're getting closer to our answer. Okay, what do? All right, we got to get all this in. Remember, we still have to fill this out, right? Remember all that? So what do we got? We got an x squared. There's nothing else that goes with that, so I'm going to put that in here. Okay. What else is here? A minus 3x. Oop, I put that too high. There, now you can see it. So take a look. A minus 3x and another minus 3x. Now those don't cancel out because they're both negative, but they are like terms. And minus 3x and minus 3x, those go together to make a minus 6x. Okay. And then finally, what haven't we touched? Well, there's that plus 9 and the positive 4. Positive 9 and positive 4, those go together to make positive 13. Okay. All right, Stove. It's been a long problem, hadn't it? Long problem. Think about what we've done, man, right? We had the zeros, we turned the zeros into factors, and now we're multiplying out the factors. However, in order to get this problem right, we have to do one more multiplication. We have to multiply this out, right? So we multiplied the two little pieces. They want us to multiply the whole gosh darn thing. So let's see. This is a trinomial times a trinomial. So we're going to draw another 3 by 3 box because we got to multiply this out. I told you that last question. That last question was crazy. It's crazy, man. All right, here we go. X squared minus 2x plus 1. I promise after this we're going to be done, but goodness gracious. I'm really surprised they asked this because this is such a time vampire. So if this is on a test or something and you have the ability to do this problem like last, do this problem last because this problem takes up some time. Hopefully you get to choose the order. Because if this was like problem number 1 on a test, shoot, you might not get to see problem number 3 because this gets crazy. Okay. All right, one more multiply. X squared times x squared is x to the 4th. X squared times minus 6x is minus 6x cubed. Just using our rules of exponents. X squared times 13 is 13x squared. All right, we're 1/3 of the way done. Negative 2x times x squared is negative 2x cubed. Negative 2x times negative 6x is plus 12x squared. Negative 2x times positive 13 is minus 26x. Again, we're in that situation where each of these little tiny pieces isn't tough. It's just there's a million of them. How are we not done with this problem yet? All right, last row. 1 times x squared is 1x squared. 1 times negative 6x is negative 6x. And 1 times 13 is 13. All right. And one thing we can say, and I'm just going to go back to it again, because we did all that garbage up top with the conjugates, do you notice how like all the numbers are pretty now? Even though this thing has a couple of ugly zeros, you'd never know by looking at it because they came in conjugate pairs and it hid the ugly. Okay, Stove. We're going to take what's inside the box, all 9 of these things. We're going to combine like terms and then we're going to be done. Okay? That's how this works. So let's see. I can barely fit the whole stupid thing on the page. Okay. So if we're looking at like terms, let's keep track of stuff. I'm going to keep track with yellow highlighter. Oh, never mind. It's a red highlighter. Okay, so that's an x to the 4th. There are no other x to the 4ths in this whole problem. And so I know that x to the 4th will be part of the answer. There's no like terms for that. All right, so we took care of x to the 4th. Now it's time for x to the 3rd. So there's negative 2x to the 3rd and a negative 6x to the 3rd. Those are like terms, so we can combine like terms. That gives us minus 8x to the 3rd. All right. All right, now time for x squareds. Y'all ready for x squareds? Here's one of them. And then there's 12 more. And then 13 more. So let's see. 1x squared plus 12x squared would be 13x squared, plus another 13x squared would be 26x squared. All right. So we did x to the fourths. We did the x to the thirds. We did the x squareds. Now it's time to look for the x's that go together. So I see a negative 6x and a negative 26x. Those are like terms. The answer is going to be negative. How about minus 32x? Right? Negative 6 down 26 more would be negative 32x. And then finally, there's a plus 13. Now, T-stove. We started with zeros. We wrote down the conjugate zero that they forgot to tell us about. We converted the zeros into factors, and then we had a great big factor multiplication party. Everybody was invited. We multiplied until we can't multiply anymore. That is the answer. That is what they assumed we would just figure out, is that we should take the thing and multiply the whole gosh darn thing out. All right. I'm assuming you're applauding, so I will bow. Oh, thank you. Oh, thank you. Oh, you shouldn't have. Oh, you shouldn't have. Oh, yes. Oh, yeah. Yep. Mm-hmm. Uh-huh. Yeah. Wow, that's a lot. I know you don't want to curse in chat. It is a lot. So the thing that you need to know is that if your teacher, hopefully, like, here's what I hope. Hopefully your teacher asks you this as a practice problem for, you to work on. And like, this is a good problem. This problem put hair on your chest, right? This is builds character. So we did this whole problem. I am confident that you could do this again. You don't want to, but you could. So let's just hope that that your teacher would have you practice this. But man, I would hope that there'd be like, hopefully none, maybe like one question where you'd have to do this on a test, because this is a time vampire. And like I said, try not to make this the first question you do. If you can push it off, then push it off. All right. So y'all have been awesome. Stove, I hope that was helpful. The next show will be Monday night. And so any questions between now and Monday night, you can, let's see, Twitch chat won't be active in between shows, but you can send them to the Everyone Loves Math hotline. You could go on my message board on my website, or you could just save them and, like Stove did, ask them in chat on Monday. But that's going to be it for me for this evening. I'm going to wish everybody a good weekend, and we will see you later. Stove, talk to you next week. Peace out.